My name's Savannah Lennon, and this is my recap of the Week 5 readings. The main physics ideas this week were that of contact forces, so tension, normal forces, and friction forces, as well as determining forces from observations of motion and finding forces from motion, both dynamic and static equilibrium. New information I learned was how to actually calculate the forces as well as the tension, and some previously learned information I had was that of normal forces and friction forces, which I've learned in previous physics courses, just not very in depth, or how to apply them in order to solve the forces on a system. So some helpful steps to solve these problems that I was given were, he said to initially start with the formula F net is equal to mass times change in V over change in T. And then first you identify your system, and then you observe the motion of said system. After this, you need to identify specific forces acting on the system by the surroundings. So that could be forces that are in contact with your system, such as the floor, or someone pushing on it, or the rope pulling it. Or they can be forces that act at a distance, which are also gravitational or electromagnetic forces. To better help see these forces and calculate them, it's beneficial to draw a free body diagram, which is just like a simple line drawing of the forces acting on the systems. And then after this, you solve for your unknowns. And he stated that you should have as many equations as unknowns, which I found to be very helpful because I didn't previously know that. And I think it is something that's good to look for when you're solving equations so that you know you're on the right track. So I found the comparison of the atomic structure of solids a very interesting comparison, but it doesn't really relate to the neuroscience field, which is my major. I thought it was helpful, however, to picture how the forces are acting on the solids and how they're stretching and compressing the different atomic bonds. I also found it interesting that by using this comparison in tension problems, you can relate a lot of the tension forces quite well to the spring problems. However, in this class, he did state that we wouldn't be using any tension problems with shear force or anything, so like side-to-side motion. And my confusing or difficult topics, I found calculating the forces, honestly, to be the most difficult part for me. But I did do some research and found some helpful websites and videos that helped me better understand how to calculate the forces. And along with this, I read the Feynman lecture and found that it was a helpful way to broaden my overall understanding of the concepts, so that in turn will allow me to apply the information better to problems I'm faced with. And I may also read the textbook, but I think these were both sufficient to explain my confusion.